5.3 Normal Distributions, Finding Values. So today we're basically going to be working backwards from where we were in 5.1 and 5.2. They're going to give us the area or the probability, and they're going to ask us to find the z-score. So we're still going to be using the chart in the back of the book, but instead of looking at the sides and going to the middle, you're going to look in the middle and move out towards the sides. Page 257 in your book has everything highlighted, so if you're having trouble figuring out the chart, I would look there to help you. Given the probability, can you find the z-score value? Yes. So why might this be useful? A university might want to know the lowest test score a student can have and still be in the top 10% of their class. That would be working backwards. A medical researcher might want to know the cutoff values for selecting the middle 90% of patients by age. Again, given the percentage, given the probability, and working backwards. So how are we going to do this? First, we're going to figure out whether the area is to the right, the left, or between two values to see if you need to edit any of the values that are given. Remember, if things are to the left, you do not have to touch anything. If things are to the right, we have to subtract from 1. And if things are between, we have to subtract their values from each other. And then step 2, you'll start in the middle of the table and you'll work your way out. To find the z-score that corresponds to the area by locating it on the table. So let's work through the example on page 257. Number 1 says find the z-score that corresponds to the cumulative area of 0.3632. And then number 2 wants us to find the z-score that has 10.75% of its area to the right. Okay, so first we have to figure out whether we're asking to the left, to the right, or between two values. Number 1 says the cumulative area. So that would mean if I were to draw it out, I'm shading all the way up to a certain point. This means this is my area. So I'm looking at something to the left. So now I'm going to go to my table in the back of the book, and I'm going to find this number in the middle of the chart. So looking around, 0.3632, I find it in the negative z-score page, is at a z-score of negative 0.3, and the column is 5. That would be my z-score. Number 2 says 10.75% of its area to the right. So if I were to draw this out, they want this part to be 0.1075. So since it's to the right, I'm going to have to subtract it from 1. To get 0.8. .925. That means that this area right here is given by this number. So now I can look in the middle of my chart for 0.8925. I know that's pretty close to 1, so it's going to be a positive z-score is my prediction. When I look in the middle of the table, I see the row is 1.2 and the column is 4. So my z-score would be 1.24. Now remember that percentiles divide parts into 100. To find a z-score that corresponds with a percentile, this is what we're going to do. If x represents a percentile p, then X% of the data values are below X, and the remaining percent of the data is above X. So if my percentile is 83, 83% of the data is going to be below, and the remaining 17% would be above. So we can say if you're in the 83 percentile for height, 83% of people are shorter than you, and 17% of people are taller than you. So example 2 says find the z-score that goes with each percentile. The 5th percentile, the 50th percentile, and the 90th percentile. Well, based off of what we had on the last slide, a percentile will always be to the left because we're talking about what's below the data. So if I were to draw out each of these graphs, this would be 0.05 would be to the left, and 95 would be to the right. This would be 50% to the left and 50% to the right. And this would be 90% to the left and 10% to the right. So in the first one, I'm looking in the middle of the chart for 0.05. Okay, looking in the middle of the chart, there is not a number that's exactly 0.05. On the chart, I'll find 0.0495, and then I find 0.0505. So this number is exactly between those. So this z-score is negative 1.65, and this is negative 1.64. So if I'm looking for the number exactly halfway between, my z-score would be negative 1.645. For my 50th percentile, I'm looking for 0.5 in the middle of my table. Okay, and the z-score that is closest to 0.5 or exactly at 0.5 would be 0, which makes sense because we know that all of our area under the entire curve is 1, and we know that z equals 0 is my mean, median, and mode. It's where I cut that graph in half. So z equals 0 is my z-score. Whoops. And the last one, I'm looking for 0.9 in the middle of the table. If I look, the area closest to 0.9 is going to be 8997. There's nothing closer than that. So I can say my z-score is about 1.28. Again, if you're having trouble seeing this, look at page 257. It'll have everything highlighted so it's easier for you to see. At this point, I would like you to stop and complete page 262, numbers 1 through 16, and we're going to add to those problems with another lesson and some more practice tomorrow. But please now stop what you're doing and work on page 262, numbers 1 through 16.